Hi, this is Chris and Jakub, and today we are going to share with you 5 lessons that we got from developing big Next.js websites. This video couldn't be done without our great team because our team provided us tons of insights about performance optimization. We asked our dev team, QA team, project management team, so we have a lot of insights, and based on these insights, we collected 5 lessons that we think are the most useful to share. So Jakub is going to share 3 technical lessons, and I have 2 management lessons. I hope this will be very useful for you. And Jakub, please give us the first lesson.
Yeah. Hello, everyone. And I also want to thank our team for providing us insights. They're very valuable for us. And thanks to them, we have the material for today. So first lesson is to use performance tab a lot. As a developers, we often use developer tools in our browsers. There is a performance tab there, which is not used that often as it should be. It's very overwhelming at the beginning and it's scary to use. But if you start using it, you will be better at it and you will see more valuable data there that you can use to optimize your applications. I personally keep trying to convince myself that there is nothing useful here, but of course I was wrong. It was just about being scared of this data. But actually you can find a very valuable timings there, like all of the network requests, code executions on the main thread. So you can find exactly which function caused some peaks in your performance. You also have data of assets which are loading and when they were loaded, and even core vitals are visible there, like FCP and LCP. So you can find a lot of useful data there. And yeah, the functions can sometimes have weird names, but it's also it forces you to a good practice to name your functions instead of using anonymous. So it will help you finding them in the performance tab. It's very often pointed out in some tutorials. I saw it a few years ago on some of them, but I was not convinced why we should use the named functions. But now I am aware of why they were mentioning that by so many times. For like a real example, what it helped us to find very bad performance on our carousel component, which was like taking 2 seconds of the main thread work, which is huge because if we switch this library, I mean, we get rid of JS almost fully. We've switched to a library that is more CSS focused and it's called, I believe, React Snap Scroll. We reduced the timing of this execution to like 100 or 200 milliseconds from 2 seconds, which is like 10 times smaller. So if you deep dive into this performance tab, you can probably find a lot of useful places where you can optimize your application. It's also very easy to test interactions there because you just you just click a button in the performance tab and the pages start being recorded. It's like a listener in background. And if you click some elements, those elements will trigger some interactions, etc., code executions, and they will be available in your charts. Thanks to that, we, for example, find out our ENP issues. One of them was with our it was Slidebox library. So if you open an image, it shows up in the extra dialog window, and you can just zoom in, zoom out, etc., go to the next and previous image. It's a very simple library, but we were fixing the performance issue with initial loaders. So we put this library on a lazy loading state, like if it's loaded only when you click on the image. And that causes us INP issue because user was not aware of any action in the background and he was clicking the image and it was like half a second of freeze.
Mm-hmm.
And yeah, all we need to do is just let the user know that there is something in the background. So we've just added a small loader indicator, and it fixed the ENP issue. But we wouldn't be able to find it without the performance tab. So it's a really good tool. Yeah, and also it helps you find which of your event listeners can cause some bad performance issues. Like a lot of scroll events is the most often problematic event listener. So if you do all of your action on every scroll trigger, it's like a lot, because if user scrolls down, it's like 100 of triggers executed. You will execute your action like 100 of times, and it's very simple fix to just add a simple if condition there and just run the code if you met your criteria, and it will also let your main thread more free for other actions. And yeah, I think that's it for the performance tab. I just enforce you to go and check it by yourself. Don't be afraid of it. Just spend some time and you will find a lot of useful data there.
Yes. So performance tab is a very scary thing. I was thinking about it like I was thinking that this is a tab designed for very old websites with old technology stack with just vanilla JavaScript, because I couldn't find any useful information for that. But after some thinking and digging, I was able to find some value. So yeah, take some time, and it will be very, very useful for you.
Yeah, exactly. Especially now in the era of frameworks, where most of the code there is triggered by a frameworks, and you need to go like a little bit deeper to find your specific functions. But it's all there. You just need to use this tool and get to know some specific places where you should look for.
Cool. Great. So now lesson 2. Implement continuous performance checks. So as you know, I'm after several leadership courses. So my lesson is about switching the mindset. The regular mindset when I'm thinking about the performance was like performance is just one step of the project. So like in the waterfall. So you have discovery stage, you have design stage, you have development stage, content migration stage, and optimization stage just before the release. And this process is not working for big projects and big websites, because on the end of the project, the code base is so heavy that it's very hard to even use performance tab and check what is going on. So code is very complicated, so it's very hard to introduce changes. You don't have time for big refactors, because deadline and time is ticking, because you are just wanted to reach the website. So this is the old thinking, and the new thinking is some kind more agile thinking, when you're thinking about performance as continuous process. So you're doing regular checks, and ideally before and after each merge to the repository. So before merging something, you're checking what are the current performance metrics and what's going on just after the merge. When you're doing code review, also you're checking your colleague code and checking if all kinds of performance good practices are included. You're checking if you have this good carousel library. You're checking if you're avoiding some unnecessary re-renders. You're checking if you have too much code on the client side, for example. This continuous process also can include adding some CI/CD tasks. So a lot of things can be do automatically, and also be aware of the tools that you have, like performance tab, Google Lighthouse. This should be part of your daily work, not just the work just before releasing the project. And this switching of the mindset, switching of the thinking will help you fix small issues before they are very big problems and you have very big pressure to release the project. Yeah, so that was the second lesson. What is the third lesson, Jakub?
The first lesson is to reduce code on the client to a minimum. We all have this problem probably in most of the projects, not only the one in Next.js and in our company, but probably all of people have some issues with that. Maybe they are not even aware of that. But yeah, in terms of Next.js, to reduce the code on the client, you must understand a key fundamental of Next.js. Like, you need to know what is served by a client to a client, what is served on the server, and what is generated during the build. So you have like three different things. And for example, in Next.js, you have two bundles or even three bundles, one for server, one for client, and even for client, you have multiple bundles because they're the code is split into multiple bundles. And yeah, you need to be very careful with importing packages. You may accidentally import like a huge server package into the client. It will be included in the bundle, but it won't be used at all. So you will just increase the size of your bundle, but you will not benefit of any functionality of the library you've imported. And also, not all of the packages that we are using from npm handle tree shaking correctly. Most of them is, but some of them is not, and it's always worth to check it manually. I mean, maybe not check, but to try to avoid it manually by just importing specific parts of libraries. So, for example, if you're using Lodash or DataFNS, they are like functional libraries. You shouldn't import directly from DataFNS. I mean, you shouldn't import full DataFNS object, but you should import specific library, specific function after the slash, like DataFNS slash format. That will make your like future process easier because you will already like reduce the amount of those extra checks that you will need to follow further. To help you eliminate this code on the client, you can use tools like Bundle Analyzer, which can show you a chart of all of the small chunks that will be generated during your build. And one of them, I mean, two of them are the most important, is the app bundle and the main bundle, which will contain most of the logic that is shared across all of your all of your pages. So it has to be as minimal as possible. The simplest solution for that is to add a lazy loading for components that are, for example, below default, so they are not visible on your first rendering, or components that can be loaded on interactions. Let's say about the first thing, above default, let's say that you have an iframe on your web, but it's like a very it's right above the footer, so you can load it when user scrolls down to a page, and getting close to it, you can use the observers to check if you're getting close, and then just initialize the loading of this iframe. And the same for components that are below default, but also you can have like components that can be loaded on specific action. For example, you have like a very complicated form, but it's only visible if user clicks a CTA button somewhere on the page. You can load this form component only when user press the CTA, unless all of your users are pressing the CTA, which is great, and I wish you that. But yeah, it's like a code that can be limited only to the people who really use it and load it when it's really needed, not like for all of them. Another example is like help chats, which are very common on the websites. Like in the bottom right corner, you have this like little icon. When you click on it, you get the like either a chat or some form or something that helps your user with their issues. And it's also not used by all of your users. It's sometimes used, so it's also good practice to load it only when it's really needed, like when user interacts on the button, or even on when it's hovering over the button, but yeah, not on the start of the page. And yeah, the less code you have on the client, the less code will be parsed, the less code will be executed, and the better the performance of your applications will be. So be very careful about that step, and it's probably one of the very time-consuming step, but it's worth to keep an eye on that. And as Chris mentioned, don't leave it until the end phase of your project. If you will do it regularly, it will be simple and not that time-heavy task. So yeah.
Okay. Thanks, Jakub. So, fourth lesson, build performance first team mindset. So this is another change of thinking, because usually we're thinking on the performance like this is a task for Jakub, this is a task for dev team, and when we are not hitting performance goals, core web vitals, for example, we're asking dev team to fix it. But sometimes it's also a bit hard and it's too late. So think about performance as a team-wide priority. And I mean by that, include that on every stage of the project, on every life cycle of the project, on every stage. So on the discovery stage, set up the performance goals. So since the beginning of the project, think how you want to design it, and how you want to implement it, and what are your goals. And your goal, like have the faster website than the previous one, it's not a very specific goal. So be very specific, and you have a lot of metrics to do that. On the design stage, it's useful to check where your traffic is coming. Maybe it's coming from some locations with a bit worse connection, or the devices are not so modern. So when you're designing the functionalities of the project, keep that in mind. On the development stage, also implement this continuous optimization that we were speaking about. Use the tools that Jakub is mentioned, and good practices. On the development stage, also it's good to have internet knowledge base. So list your libraries that you know that are good for the performance, and list the libraries that you want to avoid. On the growth stage, also you can think about the performance. For example, Jakub mentioned this live chat buttons, but do regular checks of your GTM. Maybe you have a lot of tags that are not in use, and they're impacting the performance. So this lesson is about switching the responsibility of the performance of the developer, and make it as responsibility for the whole team, because you need to think about that when you're setting up the project, when you're designing the project, when you're developing the project, and then when you're maintaining it and developing that. Okay, Jakub, so what is the final lesson?
Yeah, the final lesson is to limit data transfer to the minimum. So it's the least obvious one, but it's helping with reducing size of the page, with all of the requests wave, and all of these things are related to data. So the less the data you're passing further, the better. So avoid overfetching data and minimize prop size is like the key. By default, we push most of our data from API to the client. I mean, if you fetch data with REST API, if you are normalizing the data and passing only the required fields, that's good. You already covered this step. But if you're not, and you're just passing this data to the client, you should start cherry picking the fields that you're really using later. Unless you really are using all of the fields, then that's okay. You can't limit that. next action is like to use pagination, but on the API side, not on the client side. I saw some applications that fetch data which has like 100 items or even 1000 of items and keep it on the client, and then just handle the pagination on the client side. So if user clicks the next page, the data is already there. He has extra smooth transition, but we are like having a risk that most of our users will not even click the second page. That's a very common scenario. As I mentioned before, you are very lucky if all of your users are clicking on the second page. So it's worth to limit the data to, for example, 10 of them and just fetch 10 of them from API and use API pagination to transition to the second page. So add some loaders and just transition between those pages with using API and the client. Additionally, you can add cache, for example, to your pagination. So if your users were visiting the first page, then go to second page and then go back to first page, you already have this data, so you don't need to fetch that again. It should be cached. There's probably a lot of places where you can cache your data, which is not changed very often, and you can limit the time of the transfer. You can either create your own API routes that will cache some data for you, or you can ask your API team to add correct headers to your requests. You can also use libraries that handles cache internally in your applications, like React Query or Apollo. Another step is to use GraphQL, which lets you specify which fields you want to fetch. So that's also a step to limiting data. And yeah, I think that from limiting the data transfer, that's all. But I didn't mention in these lessons about the very obvious steps, like following the best patterns from Next.js, like using their built-in optimization tools. For example, like using Next Image for images because it has built-in optimization, etc. So yeah, the lessons that we mentioned are not the obvious one, but the most crucial ones. And just don't skip the things that are mentioned in documentation for keeping good practices, and you will be fine with your page speed.
Yes, you will be fine. And yeah, just to recap our 5 lessons. So first, use the performance tab a lot. Second, continuous performance monitoring. Third, reduce code on the client to the minimum. Fourth, build performance first team mindset. And 5, limit data transfer to the minimum. I hope this video is useful for you. If you have any other ideas how to improve the performance, please let us know in the comments. And if you have weak performance on your website, even if you are just before the release, please feel free to reach out to us. Maybe we can jump on the call and help you with that. Thanks, Jakub, for today. Thanks,
Thank you.
whole PagePro team for the insights, and see you next time. Bye bye.
See ya.